Okay, hello everyone. This is Zhihe Wang, also goes by Janet. Thank you all for attending the session and thank Cody for providing this great chance to present what I've done recently. This topic, augmented reality in room acoustics, was my thesis project of the master degree I just got. And I'm more than happy to share the achievements so far. First, something about myself. I'm a newly graduated student from the MBS program of USC. I have a lot of experience in Revit and Dynamo and believe that VR and AR technology is a very important part of the future of our AEC industry. We are now very familiar with AR technology. It has been used in many ways in our daily life now, like exhibition, education, entertainment, and many other ways. As what we can tell from its name, it's a technology that provides more information based on reality. However, all these usages are for the visual sense. But the visual sense is only a part of our reality. It's not the whole story. So what about other sense? For example, our auditory sense. On the other hand, most of the current simulation tools for room acoustics are model-based. There has to be a step for modeling the room, even for the rooms that already exist. And most of these tools are aimed at acoustic experts. People who use them has to know enough knowledge to understand their settings and the parameters, which can be too hard for ordinary people to use. Therefore, I'm trying to develop this easy-use room acoustic simulation tool, which named Soundar. It's a tool on mobile platforms using AR techniques to simulate some simple acoustic performance based on existing room and virtual sound sources, and then provide auditory results, which means the users can actually hear it. The current Soundar 1.0 is aimed at small, enclosed, and simple rooms, which means it's not for large-scale spaces like auditoriums and concert halls. It cannot be used on outdoor or semi-outdoor spaces. It currently can only work on the rooms with straight and plain surfaces. Soundar is designed for ordinary people. You don't have to be an expert to use this application. And it can be used in many daily occasions. For example, if you want to change the decoration of your bedroom to make it more quiet and more sound comfortable, you can use Soundar to test the materials to see which design has the best performance. Or imagine you just bought a new stereo and don't know where to put can provide the best sound quality. It can also use to predict proper volume. For example, how loud should I speak in a lecture room to make sure the people who's sitting in the last row can clearly hear me, or if the background noise is too loud to cover what I'm saying. Soundar is designed for both iOS and Android systems, and used Unity as the development platform. AR Foundation is a software development kit in Unity, which used for creating AR environment and supports both iOS and Android system. Steam Audio is used in Soundar as the audio renderer, which can provide binaural audio. And the whole application was developed using C# scripts. The structure of Soundar is mainly scene-based. Each scene has its own main script, and instead of writing everything in one super long main script, Soundar used a modular design method, which each module focuses on one simple task. These modules are called in the main script and even called by each other. Now let's meet the prototype of Soundar and see what it can do. When we start Soundar, it firstly shows the logo and the reminder to make sure the users are wearing their earphones. Then it guides the user to calibrate the volume setting of their devices. The calibration plays a constant sound. It guides the user to turn up or turn down their devices to make sure the simulation later will play in a proper and more realistic volume. I don't know if you can hear the constant sound right now, but it's barely heard. That's the purpose. Then we start to set up the room. The room is built by floor vertices and the ceiling height. So we collect the vertices by touching the screen. And it will enclose as a surface, then to a qubit. The default materials are assigned to each surface. And to change the material, we can go to the edit mode and change it by touching the surface. The current prototype has only limited material options for each type of surfaces. More options will be added in future versions. After the room is set up, we're going to set up the sound sources. By touching the screen, a new sound source is generated at the position of the phone camera. Then point the toggle, we can hear the result of the simulation, and it shows the decibels of the sound source. If we don't like the current sound pressure level, we can go to the edit mode to change it to another value. If we don't, Sounder has different options for the sound file, including impulse, constant sound, music, and voice for both male and female.
Madam, this is the best brand of corn. Acid burn.
By pointing the plus button on the up corner, it can add multiple sound sources. Each sound source can have their individual sound pressure level and its own sound file.
Madam, this is the best brand of corn. Acid burns holes in wool cloth.
The sound sources can be temporarily muted.
Madam, this is the best brand of corn.
Or it can also be directly deleted. The location of the sound source is also adjustable, so we can move it around to any position we want it to be. You don't have to climb to get your camera phone to a high spot by using this moving function. Here comes the most exciting part, the simulation. Sounder firstly records the background noise for 3 seconds and plays it with the simulation result. This provides a more accurate sound pressure level at calculation and more realistic sound feedback. The scale at the corner shows the reverberation time of the room and the real-time sound pressure level of what the user heard. When we go closer, it turns louder. And if we go further, it sounds quieter. This auditory feedback is also binaural, which means we can tell the relative position of the sound source based on what we hear. But unfortunately, this video is recorded by the built-in screen recorder of my own phone, which is single soundtrack. That's why we can't hear it, but hear the binaural feedback right now. There are some small functions in the main menu, including the visibility of the scale and mute on sources at once. The scope of this prototype is now limited by many reasons, like the development time, the team size of developers, which only me, and the knowledge of coding, and also funding. Once these problems are fully solved, Sounder may have more possibility to provide more accurate feedback for scientific use and be available in more comprehensive situations, which can create a higher value. More functions can be added based on the current structure. For example, it can allow users to edit the position of the room vertices, separate the surface into parts and assign different materials to them, add content library which allow users to add furniture and people in the room. For the sound source, it may add more options on sound form. So besides the point source, it can also be semi-sphere, quarter sphere, liner, etc. And beyond these, there are more possibilities of Sounder. The shape of the room is now limited as a shoebox, but can be more complex, even like organic shapes with curves. The maximum size of the room may also be increased so that Sounder can be used in simulate larger spaces. Real-time ray tracing simulation can also be very very helpful for users to learn about the sound performance in the room and see the virtual sound rays bounce in the real room. Furthermore, sounder may also move to other devices one day, like goggles, which have a better environment detection and a relatively settled quality of the earphones. I hope these ideas can become true one day, and I know it won't be soon, if only by myself. So please contact me if you are also interested in this project. Finally, I would like to thank my thesis committee members for the help during my research. And thank you all for your time and attention. Please feel free to contact me if you're interested or if there's any questions. Thank you.